Okay. So we just saw that when we consider arbitrary coordinate transformations, the differentials of the coordinates that transform according to this rule, dxi prime equal to dou xi prime by dou xi prime by dou xj dxj. And then the partial derivative of a function u, it transforms according to this rule. So du dou u by dou xi prime, it transforms according to this rule. Dou xj by dou xi prime. Okay. Dou u by dou xj. And we just saw that these two partial derivatives are different when we consider arbitrary coordinate transformations. So we can define two types of vectors. Okay. So based on arbitrary coordinate transformations, we can define two types of vectors. So let us first define one type of vector, and that is called contravariant vector. Let me use a different color here. So it's contravariant vector. C-O-N-T-R-A-V-A-R-I-A-N-T. Contravariant vector. Okay. So what is a contravariant vector? V, the vector V is called a contravariant vector if its components which are given by Vi prime, sorry, Vi, they transform according to this rule, dou xi prime by dou xj Vj. I repeat, so if V is a vector, if V is a contravariant vector, then the components of V, they transform according to this rule. That is, the components of the vector V, if they transform according to the rule followed by the differential of the coordinate. Okay, so this transformation and this transformation, they are the same. Okay, so if the transformation equation of the components, they are the same as the transformation of the differentials of the coordinates, then we say the components Vi, they are components of the contravariant vector. Haningbadi contravariant vector ki components inje coordinate differential and transform tawba admaina transform tawe under an arbitrary change of coordinates. Okay. So this is how we define a contravariant vector. Then the second type of vector is called covariant vector. Okay, covariant vector. So covariant vector di come down on covariant vector di suppose u is a covariant vector. Oh, sorry, I have already used u to represent a function. Okay, so let me still use v, no problem. So if v is a covariant vector, then the components of this covariant vector, they transform according to this rule. That is, vi prime is equal to dou xj by dou xi prime vj. Okay. So if the components of a vector transform according to this second rule, then we say these components are the components of a covariant vector. Okay. So if you look closely, this transformation is the same as the transformation of the partial derivatives of a function u. Okay. Aduna haibidi kaino? Aduna haibidi. Sina haibidi kari kari khange from this four equations. What can we see? So let me use the spotlight. So from this 1, 2, 3, 4, 4 equations, we see that the differentials of the coordinates are actually the components of a contravariant vector. Okay, and what is the contravariant vector? The contravariant vector is simply the displacement. Okay, and similarly, we see that the partial derivatives of a function, they are the components of a covariant vector. Okay, you can see that here the prime appears in the numerator for the covariant vector, whereas for a for a contravariant vector, the prime appears in the numerator, and for a covariant vector, the prime appears in the denominator. So the differentials of the coordinates, they are contravariant vectors. Sorry, they are the components of the contravariant vector, and the contravariant vector is the displacement vector. And then the partial derivatives of a function, they are the components of a covariant vector. Okay, so we have defined two types of vectors, contravariant vector and covariant vector. Now let us look at the notations which are generally used. So let me draw a line here. So let us look at here. Sorry. Let us look at the notation. Okay. Okay. So it is customary to write the indices of contravariant vectors and tensors as superscripts rather than subscripts. Okay, I repeat, it is customary to write the indices of contravariant vectors and tensors as subscripts rather than as superscripts. The indices of contravariant vectors are customarily written as superscripts. So here this definition, if we use the customary notation, then it will be written like this. So it should be vi prime, actually v prime I. So the ith component of v prime, I repeat, the ith component of v prime, that is equal to dou x prime I, that is the ith component of x prime, dou x prime, and dou x j vj. Okay, so we saw that vi from this equation, if vi are the components of a contravariant vector, then the indices should be superscripts. Okay, and for this covariant vector, it should be written like this. It should be vi, so v prime I, this is equal to dou xj by dou x prime I vj. You can see that I have raised the indices in the partial derivatives, because dou x here, dou x are actually small displacements. Okay, so these are actually differentials of the coordinates, and we just saw that the differentials of the coordinates, they are components of a contravariant vector. So I have raised the indices of x prime and xj, because these are, when we look at dou x and dou x prime I and dou xj, these are actually the components of this. Numerator is the component of a contravariant vector. Similarly, the denominator is also the component of a contravariant vector. So I have raised the indices here. So so this is how we customarily write the components of a contravariant vector, and this is how we customarily write the components of a covariant vector. Okay, and here we are still using the summation convention, and the summation convention now appears to a pair of indices. Here we should see that j is an upper index, and this xj, since it appears in the denominator, we consider it as a lower index. So summation is between an upper index and a lower index. Here j is a lower index, and here this xj, it is in the numerator. So this is an upper index, this is a lower index. So summation is always between an upper index and a lower index. Okay, so I'll pause the recording here.